Welcome to episode 8, where we're following the KidsCanCode tutorial using Monogame, Pygame and Love2D. Today we're doing the Pygame version, which we have refactored compared to the original. So I'll just show you what today is all about. It's explosions. Now got graphics as we are blowing up the meteors, and when the player is destroyed, not only is there an audio explosion, we now have, there we go. So that's what we're doing today, explosions. Now the explosions are not available anymore from opengameart, so I've included them in the distribution here. Under explosions there's a zip file there, and a credit to Kenney, the guy who originally made them from opengameart. There's also a link to the same set of explosions in the KidsCanCode download, but I thought it was only fair not to take everything from his personal website, so they're up here for you to make use of. So the explosions themselves, if I can open the image folder here, we've got, what we're dealing with today is 8 regular explosions and 8 sonic explosions. So the regular ones are for the mobs being hit by the bullet, and the sonic ones are for the player being hit by a mob. So that's the ones that we're going to be including. So let's first of all go to the load. There's no change to the main folder here. So load, we've now got a new one called load animations. I've called them animations because that's kind of following on from the original tutorial, but of course they are this series of 8 images per explosion which we're going to be loading in. So load animations, these images are being scaled, and we're making 2 sets. We're going to make a large explosion with the LG key to the dictionary, and a small explosion which is for the smaller ones, and there's also one of course for the player. So we've got 3 animations there, which means of course that up here in the explosions list we've got an explosion anim dictionary, which is where we're going to load all the images in, and a list of explosions which we'll be using with the game as we're playing it. So the dictionaries are acting as the storage for them, and then the list of explosions is similar to the list of mobs or the list of bullets. It's just a way of holding the current explosions that are going to be happening during the game. So animations, we've got as before, we're going to use the image folder and create a path, or we created this last time when we were doing our images, and then this time, because we've got a series of images, if I could just open that again, which are similarly named. For example, if you've got regular explosions 00, 01, 02 and so on, so we can kind of play with this a little bit to load them in by using this interpolated string here using the lowercase f. So we're going to be, the file name is going to change depending on the value of I. So in this for loop it'll start off at 0, and then we're going to, the file name will be regular explosion 00, because I will be 0 png, and then we're going to load in each file, convert it into an image, set its color key, and then transform that image by this amount, 75 by 75, to create a large explosion, and add it to our large list. And then we're going to transform the same image smaller and add it to our small list. And then finally we're going to load in the sonic explosion in the same manner by using this interpolated string, so that we do the same thing with that, load that in and put it in the player list. So this one for loop here takes each of the regular explosions, scales them up or down, I should say, to fit into a large collection, a small collection, and then finally takes this sonic explosion for the player and puts that into the player dictionary there. So we've got all our images are already pre-sized and ready to use. So that's how the load animations works, by just storing each of those. Now of course we're going to need an explosion class to deal with these. Let me just get that viewed. Explosion, there we go. So again, this is a proper class. We're creating an instance of an explosion each time we create it, so that if we hit multiple mobs as we're going along, these can all be playing out in turn. So the way that this works is that the images that are supplied to it is one of those sets of 8 images, pre-sized, ready to go, ready to play. So we've got a set of 8 images that is passed in to the constructor here. The position it starts off is also supplied as center, and that will be, of course, in the case of a mob, the center of the mob, so that the explosion appears to come from the center of the mob as it blows up. The way this works is that we're going to play the images one after the other after a set time has passed. So we'll set the images set here is all 8 images. Then we've got a self.image, which is the sort of current image, and for this one we're using the first image. So that first image is our one that we're starting with. So we're getting a rectangle from it, we're getting the center of the rectangle, or setting the center of the rectangle, I should say, from the center that we passed in. The frame is set to 0, the time passed is set to 0, and this self frame rate is how often do we want to change the frames. So I've set it to 0.1 seconds. So that means that each explosion will last 0.8 seconds, because there's 8 images and we've set it to 0.1 frame rate. So every 0.1 seconds the frame will change. So in order to get that working in the update one here, we are increasing the self.time passed, which started off at 0, by delta time, and then we're checking, has the time that's passed reached the frame rate that we set up here. So every 60 times a second this thing will fly through, and then if delta time has increased sufficiently so that 0.1 seconds has passed, then we reset the time passed, and then we increase the frame to the next available. So if it was at 0, it then becomes 1, and so on. Then we're checking whether that frame number has gone above the length of the images, because at the moment we know we're supplying 8, but this could also cater for maybe 7 images or 10 or whatever you wanted. So by keeping it generic there, we're just going to increase it until we reach the end of the length of the list of images. When that happens, we're going to set self active to false. Remember, this started off at true, so once we have reached the final frame, active becomes false, the explosion has finished. So as long as it's not reached the end of the frame, then we're going to change the or keep the center of the rectangle here, but change the image to the next frame, so that goes up by the current value of the frame. We'll get its rectangle, set its center, and so on, so that we're constantly making sure that each image, and they are slightly different size, these images, the center of it remains in one place. And the drawer, of course, nothing complicated about that. I haven't bothered with any rectangles surrounding them. Here we're just blitting the image, single image, to the screen inside its rectangle. So that's how the explosion class works. So we're cycling through 8 images dependent on the time that we set, which in this case is 0.1 so it's 1 frame per 0.1 seconds, so that all 8 images will have gone through in 0.8 seconds, and I think that works quite well, but of course feel free to play with that. So that's the class. Let's have a look how it works. So we load it in from the load here by calling this new function, load animations. The rest of it is the same, this is nothing new here. Then we load in the animations, and then in the update one, we now got a new function called update explosions. So this could have been done directly in here, but I always like to kind of separate things out. So we've now got an update explosions one, which is this one here. So that takes delta time, and it goes through each of the explosions in turn and tries to update it. And what will happen when we are updating is, if there's a frame still available, the update will be returned as true, but if we've run out of frames, it'll be returned as false. A similar principle to what we've been using in all the other classes so far with the player alive and so on. So the explosion, if it can't be updated, then we're removing it from our list of explosions. And the date of death explosion is to do with the player. We'll come back to that in a moment. So we're currently talking about the ones where the mobs are exploding. So let's see how we initiate that. So in the check mob bullet collisions one, so what we're checking is whether the circle of the bullet combines with that of a mob, in which case we've hit it. Same as before, we're playing our explosion sound, then we're removing the bullet. Now here I've set it, the explosion size, to be small, but if the radius is greater than 25, then I've set the explosion size to large, so that it automatically will play the correct size of explosion depending on the size of the meteor. And here we're appending that to our list of explosions, which is set up here, of course, explosions here. Appending to it a new explosion, so we're calling our class, and we're passing the animation series depending on the size that we've chosen, which is here, and the center of the rectangle is the starting point. So when we call a new explosion, we're passing to it a list of animations, the center of the mob, and the size of the explosion, and that creates our explosion for us. So that's how the explosion is started. Then it's updated using this, and finally it is drawn down here for explosion in explosions, and then we draw it. Now the second one, which is for the player, is initiated in the check mob player collisions here. So as before, we're checking to see whether the player is alive, as we did before, and as long as it is, then we're going through the mobs. We're bashing at the shield of the player. If the shield drops below 0, then player alive is set to false, and then we are adding a new explosion to our sorry, we're not adding this to our explosion list. This is dealt with separately. So we've got this data.death explosion, which is set up here. There we go. So that was set to none initially. Okay, and then we've got the data.death explosion is set to a new explosion, using the same kind of formula as we did for the mobs. So a new explosion in, and then the series of animations are supplied with the player's center as the center point for the explosion, and then size, of course, is the player. So that will then pick the third set of explosions that we've got, which is the sonic one, which is a much bigger explosion. So when that is updated, we check whether the death explosion exists or not, because initially it will be none, and it's only when the player is hit that the data death explosion is given a real value here. So in the update section, if we've actually got a death explosion running, again it will just check to see whether that can be updated so that it will run for its 8 frames, and then if it can't be updated, it's set to 0. The thing again is drawn down here with this section here. So if the death explosion is none, then we just draw the player, whereas if the death explosion exists, then obviously the player is dead, so we don't draw the player. Instead we draw the death explosion. So that's how that separates out between whether we're drawing a player or we're not, because the player is now gone. Let's just check whether there was anything else we needed to look at there. Yes, when the player's death explosion is running, it's also, if you remember, playing the data die sound, the die sound of the explosion, and we're using that sound, which lasts a tiny bit longer than the explosion, to declare when the player is actually dead. So we're only, first of all, we're checking, is the death explosion equal to none? If it is, then we're then checking whether the die sound is running, and if it's not, then we quit the game. So the game will only quit, first of all, if the death explosion has been completed and it's no longer running, and if the die sound has also stopped. So that's why that will keep going until the explosion is finished. So I'll just show you that again by playing it once more and just dying. So I'll try and get in the way of as many. There we go. As you saw, the explosion there, quite a large one at the end, and once the visuals and the sound finished, then the game stopped as well. So that's how we're dealing with explosions.